Good morning, students. Good luck on your notes.
Okay.
Goodbye. I'll see you later.
No, you won't. Go away.
Yes, I will.
All right. If you guys could please pause the video at this time and write down everything that I have written here, and then I'll go through what this all means. A sequence is a function with a domain that is the set of positive integers, also known as the natural numbers. The terms of the sequence are the range elements of the function, and they are denoted as a sub 1, a sub 2, a sub 3, all the way to a sub n. A sequence can be finite or infinite, and there are two different ways to write a formula for the terms of a sequence. A term in a recursive sequence depends on the previous term. Any term in an explicit sequence can be found using the formula. A sequence that approaches a specific value is said to be convergent, otherwise it is divergent. For a convergent sequence, the limit on a sub n as n approaches infinity does exist. So first off, I wanted to discuss the idea of a sequence being convergent or divergent. Each of these represents different sequences. Now, when n is equal to 1, you're going to see that we have a specific value. So let's just say this is n equal to 1. And we have a specific value that will represent what the sequence equals when n is equal to 1. Notice this next dot would be maybe when n equals 2, and you're seeing a different value. N equals 3, n equals 4. So you can kind of think about each of these as being different n values, and wherever they are at is the sequence value for that specific n value. With that being said, you'll notice that for this first example, these are not approaching a specific value. They're all over the place. One gets bigger, smaller, and there's no rhyme or reason to this. You're going to see that this is what we call a divergent sequence. The values are diverging. They're not approaching a specific value. Whereas if you look at problem 2, notice what appears to be almost like a horizontal asymptote. If you look at each of the different terms of this sequence, you can see that we go up, down, but then it all starts to approach this specific value. You're going to see that it's leveling off at a specific value, and we call this convergent. It's converging to a specific value. Now, for the third example, you're going to see that this is definitely a situation where we would say that this is converging on a value. Each term of the sequence is getting closer and closer and closer to that same value. And then finally, this last example definitely would be divergent. Each term of the specific sequence is getting larger and larger and larger and larger and would be increasing. It's not approaching a specific value. Now, let's look at a specific sequence and talk about what we're going to have to do to find different values of the sequence and then write possible rules. The first sequence that's given to you, notice that it's given as a list of numbers. -7, -4, -1, 2, 5. This right here represents a sub 1. This is a sub 2. This is a sub 3. This is a sub 4. And this is a sub 5. So if I wanted to identify the pattern, we need to look at what is going on with -7 to make it -4. What is going on from -4 to make it -1? And it has to be the same thing. We can't have something happen for 2 terms, but then something different happen for the other. Well, maybe you'll see right away that we're really just adding 3 to get to the next term. And this works for all terms, which you always have to check. So in this case, the pattern is that we are adding 3 to each term. Now, if I wanted to find the next 4 terms of the sequence, notice that I could say a sub 6 equals, and then if I added 3, it would be 8. And then if I said a sub 7, if I added 3 to 8, I'd be at 11. And then a sub 8, if I added 3 to that, I'd be at 14. So you can either list it like that, or you can just say 8, 11, 14. Now, we're going to talk later on how to write explicit rules and using formulas, but I just want you to note, because this becomes important later on, that the value we added became the slope of this explicit formula. I also want you to notice this -10. With linear equations, this would be your slope or your y-intercept. And I just want you to think about how if this was the first term and I said find the 0 term, notice that if I subtracted 3 and went the other way, I would get -10. So just kind of something for you to note, that we're basically creating a linear equation because we have this constant rate of change of adding 3 to each term. So that's something we'll get into later. Now, what you do need to know for today is this idea of writing a recursive rule. So as before, I would like you to pause the video and I would like for you to copy down everything I have here and then resume the video once you've copied it all down. In order to write a recursive rule, as you'll see, you need to have two different things stated. You always have to state what the first term is. You have to do this. A recursive rule depends on the previous term. So if you don't tell me what that first term is, you can't get to any of the previous terms. So for this specific problem, notice that our first term was -7. So the first thing you have to have when writing a recursive rule is say a sub 1 equals, and in this case it was that value of 7. False, -7. The second thing you need to have every time you write a recursive rule is a formula to find the next term, but using the previous term. Now, what do I mean by that? To write a rule, you're going to say a sub n equals. Now, somewhere in this rule, you have to have a sub n minus 1. This represents the previous term. So if I want to find the second term, this will represent the first term. If I want to find the third term, this will represent the second term. Now, the previous term, if you think about finding, let's just say, for example, a sub 2, notice that if I fill in a 2, it would be a sub 1 when I do that math. So what do I do to a sub 1, which in this case is -7, to get to that second term of -4? Well, we already said you add 3 to it. So you basically are just writing this out and saying, well, I took the previous term and I add 3 to it, and that'll get you to the next term. So think about this. If I wanted to find a sub 3, so this is actually our answer, but I just want to show you how this works. If I want to find a sub 3, I could fill in a 3 for n. And notice that this says I would have to find a sub 2 and add 3. Well, notice if we took a sub 2, which was -4, and add 3, that would get us to -1, which is that third term. So you're going to see if you wanted to find, for example, a sub 100, you would have to know the 99th term and add 3. So clearly, recursive formulas are okay for small sequences, but if you wanted to find the 100th term, it would take a lot of time to find all the terms leading up to that 100th term, so then you can take the 99th term and add 3. So that's the drawback of these recursive rules, is that you'd have to find each term that came before. Now, if you want to determine if a sequence converges or diverges with a formula, I mean, just think about this pattern. If we keep adding 3, adding 3, adding 3, these numbers aren't getting smaller and smaller. They're getting larger and larger and will continue to get larger and larger. Therefore, we would say that this is a diverging sequence. Diverge. It's going to keep getting larger and larger. In fact, it would look like a linear equation. We don't really see one here, but it would be a situation here, like number 4, where the numbers just keep getting larger and larger, but more so in a linear fashion. So that's basically how this is done. Let's look at another example just to see that we understand this. For this next one, you'll notice that the same pattern is not working. I'm not subtracting a number each time to get to that next number. And I know that because just even looking here, this would be subtracting 6, but I don't see that same thing happening here. I'm not subtracting 6 to get to 9. So unfortunately, this is not going to be just adding or subtracting a number in order to get to that next term. I do know, though, that if I look at 9 and 3, that if I think about multiplication or division, two other operations, if I take 9 and I multiply it by a third, that does give me 3. And if I do that same thing to 27, I also get 9. And then that also works here. Now, some of you may have seen that already and said, well, I didn't think multiply by a third. I thought divide by 3. It's the same thing. So you could either divide by 3 or multiply by a third. Later in the unit, you'll see the value of multiplying by a third versus dividing by 3 when we write these formulas. Now, if I wanted to write the next 4 terms of the sequence, again, think of this as a sub 1, a sub 2, a sub 3, a sub 4. So if I wanted to find a sub 5, I need to take 3 and multiply it by a third. So I would get, I'll show that work, a value of 1. And then if I wanted to find a sub 6, I would have to take 1 and multiply by a third, and I'd get a third. And then if I wanted to find a sub 7, I would have to take a third and multiply by a third, and I'd get a ninth. And then finally, for that 8th term, I would have to take a ninth and multiply by a third, and I'd get 1 over 27. So you could write it as I did, or you can write each of those in a list. Now, again, we'll talk about writing explicit rules for the sequence later on. I just want you to note the answer, and I want you to notice this is just exponential. This is what we did last unit. We take that starting term and we keep multiplying by a third, and then notice this n minus 1, because if you want to find the second term, you're only going to multiply by the 1/3 one time in order to get that second term. So again, we'll talk about that more, but I just want you to note that explicit formula is everything that we did last unit. It's just an exponential equation here. And again, we will get into that later on. What I do want to focus on, though, is writing this recursive rule and then talking about if the series or the sequence converges or diverges. So with that being said, if you want to write a recursive rule, remember what I said before. You have to write out what that first term was. So I have to say a sub 1 equals 81. Must be there. Now to write the rule, you have to think about including this a sub n minus 1. Because that means if I want to find the second term, I need to know the first term. If I want to find the third term, think about doing 3 minus 1. I need to know the second term. Well, what am I doing to the previous term in order to get the next term? So if you look, what did I do to 81 to get 27? Well, I multiplied it by a third. So I can say 1/3 times a sub n minus 1. Because think about it. If you want to find, and just always test your rule if you want to make sure it works. You can think about if you want to find a sub 2, you would take 1/3 times a sub, and then when you do the math, 2 minus 1, a sub 1. So you would take a sub 1, multiply by a third. Well, that's exactly what we're doing to get each term of the sequence. Now, finally, will this converge or diverge? Well, think about this. This is exponential. Even though we aren't learning the equation today, even just think about what's happening to these terms. I keep multiplying by a third, by a third, by a third. These are going to approach a horizontal asymptote value. These are definitely going to converge, and specifically, they're going to converge to 0. Okay, think about a horizontal asymptote here. Think about what value we're adding or subtracting at the end of this formula. It really would be 0, and remember that that value is always your horizontal asymptote value. So as a result, you're going to see that this right here is going to have this approach 0 and would converge.